Okay, listen, if a building can't build itself, then how did the human heart, DNA, giraffe necks, and a watermelon pull it off? Let's talk about some seriously mind-bending examples of design in nature that make you go, there's no way that's random. So imagine dropping Legos from a balcony. How many tries until you get the Eiffel Tower? Right, never. Not in a billion tries. Now think, your heart beats 100,000 times a day. Without you asking. It syncs, it repairs, it adjusts. You never even get a low battery warning. And your eye, it's got 120 million rod cells and 6 million cone cells. Each cone can detect a million colors. That's more than a 4K screen, with built-in autofocus, made out of meat. Check this. An archerfish spits jets of water to hit bugs above water, correcting for refraction, gravity, and air drag. Real-time physics, no calculator. How does a fish know trigonometry? Or the Venus flytrap? It counts. Waits for exactly 2 touches in 20 seconds before snapping shut. That's a trap with logic gates. And why does a bee fit perfectly into a flower? Why does a mango have just the right sugar for the animals that spread its seeds? Cow milk has perfect ratios for baby mammals, almost like it was intended to nourish. And bananas? They curve towards sunlight, growing up even when gravity says down. That's a fruity rebellion against physics. Want more? The mimic octopus copies 15 different sea creatures. Bombardier beetles do literal chemical warfare. Mini explosions from a bug. Wood frogs in Alaska freeze solid every winter. Heart stops, thaws out, hops away, and hummingbirds' wings flapping 80 times a second, hearts beating like jet engines. So, is all this chance? Or is there something deeper going on? You don't have to believe in anything, but man, it sure looks like a plan. Because honestly, if a smart fridge can't build itself, what are the odds that you did?
Have you ever seen a skyscraper just pop up out of the ground all by itself? Of course not. Buildings need blueprints, architects, and construction workers. You can't just leave a pile of bricks and expect a tower to assemble itself. It takes intelligence and planning to make something so complex. Now think about something natural, like a watermelon. It starts as a tiny seed, and with just dirt, water, and sunlight, builds itself into a giant, delicious fruit. Or a cow, a walking milk-making factory that builds itself from a single cell with a heart, lungs, and 4 stomachs. Here's the big question. If a skyscraper can't build itself, how does a cow, or your own eye, with its self-focusing lens and built-in cleaning system? Your eye is a masterpiece of engineering, yet it just grows with no visible architect. We see design everywhere in human creations. A watch, a car, a computer. But nature's designs are even more complex and efficient. From the veins on a leaf to butterfly migrations, the world is filled with what looks like genius-level design. Is it all just a happy accident? Or is there something more going on here? Let's consider the evidence. Imagine a box of billions of Lego bricks. Shake it all you want. Will it ever build a space station? Not a chance. You need instructions, a plan. Every living thing has one DNA. DNA is the ultimate instruction manual, written in a 4-letter code, telling every cell how to build and run a living thing. A single strand of human DNA contains enough information to fill 1,000 books, all packed into a cell you can't even see. This code isn't just a list of parts. It's a dynamic script, telling cells when to divide, what to become, and how to work together. It tells a seed how to sprout, a caterpillar how to become a butterfly. This isn't just a blueprint, it's a self-executing program of immense sophistication. So, if shaking Legos won't build a space station, how could random processes write a code more complex than any human invention? The idea that this precise, information-rich code just appeared by chance is a real puzzle. It makes you wonder, doesn't it? Let's talk about perfection. In engineering, we strive for efficiency, but nature is the true master. Your heart is a pump that beats 100,000 times a day for a lifetime, adjusting automatically. No battery required. Your lungs, with a surface area the size of a tennis court, extract oxygen with incredible efficiency. Your brain, a 3-pound marvel, uses less power than a light bulb, but stores a lifetime of memories and solves complex problems. Even a banana is a work of art. Biodegradable wrapper, color-coded ripeness, perfectly shaped for your hand. Everywhere in biology, systems work together in harmony. The digestive, immune, and nervous systems all interconnected. It's not just one clever trick, it's a universe of them, all working at once. This isn't just good design, it's breathtakingly brilliant, making our best technology look like toys. Nature's engineering is so integrated and efficient, we're only beginning to understand it. The more we look, the more genius we see. Is it all just luck, or is there a deeper plan? Nature is full of engineers, chemists, and physicists. The archerfish hunts by shooting water jets, calculating physics to hit its prey. The Venus flytrap counts touches before snapping shut, saving energy for real meals. Bees build perfect hexagonal honeycombs and communicate flower locations with a symbolic dance. The woodpecker's skull absorbs massive impacts, letting it hammer trees without harm. These aren't random behaviors. They're brilliant solutions to complex problems. The archerfish's aim, the flytrap's trigger, the bee's dance, the woodpecker's shock absorbers, each looks like an invention. If a human made any of these, we'd call them genius. In nature, this level of brilliance is everywhere. It's so common we forget to be amazed, but we shouldn't. Nature's genius is astonishing. Let's keep looking. The wonders keep coming. A cow's stomach turns grass into milk. Coral reefs, built by tiny polyps, support a quarter of all marine life. The bombardier beetle mixes chemicals to create a boiling spray for defense. The wood frog survives frozen winters, then thaws and hops away unharmed. The octopus changes color and shape instantly, squeezes through tiny gaps, and solves puzzles. Our best technology can't match these feats. So is all this complexity and coordination just a series of lucky accidents? Or does it point to a deeper intelligence, a blueprint woven into the universe? Maybe the greatest discovery will be finding the architect. The investigation continues. Consider the evidence.